Hello students, how are you? I hope all are you fine and doing well in your studies. You're welcome to Kshreekar Educational Groups. Today we are going to discuss about integration. In previous lectures we already discussed about trigonometry, function and differentiation. So let us start integration. As we can see here in definition, integration is the inverse operation of differentiation. What is the integration? Integration is the inverse operation of differentiation. So in integration we add multiple parts or objects of same dimensions or same value, but in differentiation we break a big quantity or a big object in different parts of same dimension or same value. So integration is the inverse operation of integration. Okay, as you can see here multiple boxes are present and each box have same dimension. When we add them, then a long rod is being made of length y. It means we can say that we did the summation of them, so we can write here summation of dy is equals to y. As you can see here, symbol of integration can be written like as. This is the symbol of integration. To represent the integration we can write integration of fx dot dx. Here function is fx and it is multiplied by dx, that means dx is being multiplied by function fx. Function may be different here, and integration which we get here is dx times of function of x. Let's move further. There are two types of integrations. First one is definite and another is indefinite. Definite integration, there will be limit, but indefinite integration has no limit, it is limitless. First talk about definite integration. Here is in formula as you can see here. In this formula there are two limits, lower limit is a and upper limit is b. And the result we get will be under both limits. But as you can see in indefinite integration there is no limit. So we get answer here without limit. Let's see some integration formulas which you have to be remember. First formula for integration is integration of x raised to the power n dot dx is equals to x raised to the power n plus 1 upon n plus 1, where n should not equal to 0. Second formula is integration of 1 upon x dot dx is equals to ln mod of x. Here ln is logarithmic function. Now we move to the third formula, integration of e raised to the power x dot dx. This is the exponential function, so the integration of e raised to the power x dot dx is equals to e raised to the power x. Now we moving to the fourth formula, it is written as integration of a raised to the power x dot dx. And integration of this function is a raised to the power x upon ln a. Where a is the constant. Move to next formula. It is written as integration of sin x dot dx. We can write the integration as minus cos x plus c. Next formula is integration of cos x dot dx is equals to sin x. There are many other formulas like as. And you have to remember these formulas. Because we can't do anything in this, you have to remember this formulas and put the value and find out the result. It's okay students. Now let's move to the operation of integration. There are multiple rules of integration. As we can see that. The first rule is constant multiple rule. It is written as integration of k dot fx dot dx is equals to k. Integration of fx dot dx. Here k is the constant. So when constant comes with function, then constant term can't be integrated. Because it is already integrated a whole number, so we take outside the constant term from integration sign. Now let's move to the second rule, that is addition and subtraction rule. As you can see here there are two functions, first one is fx and the second one is the gx. Both functions are added to each other by plus sign and subtracted by each other by minus sign to integrate this whole term with respect to dx. When you add them, you have to apply plus sign. When you subtract them, then you have to apply minus sign to integrate them. Oh, it's a silly thing. We separate both the functions and integrate them. Now let's move to the third rule, that is integration by parts. In this there are two functions in multiplication form. First one is u and second one is v. These functions are functions of x. In this situation we have to apply the formula to integrate it. As you can see here, u integration of v dot dx minus differentiation of u integration of v dot dx. As you can see here, u dash is the differentiation term of u, then the whole term will be integrated by dx. Now let's move to the next rule, that is substitution rule. In this rule you can see the format of integration of f gx dot g dash x dot dx. Here you can see that the function is under the function and the differentiation of main function is multiplied by a function of gx. In this situation what you have to do? You have to substitute the main function by another term. Here we are going to substitute gx by u, then we take the differentiation of gx and it is replaced by du. Here you can't understand these rules, so we take some examples here, then try to understand them. Our first example is integration of 4x raised to the power 3 dx. As you can see here, this example based on constant multiple rule. Here 4 is the constant and x raised to the power 3 is function. So to solve this we have to take 4 outside integration. And we only integration x raised to the power 3. To solve this we apply the formula x raised to the power n is equals to x raised to the power n plus 1 upon n plus 1. Here n is 3, so the integration will be x raised to the power 3 plus 1. So upper term will be x raised to the power 4 and lower term will be 4. So now 4 cancel 4 and we get this final answer. We add a constant term here. It's a rule in integration, we always add a constant after integration. Let's move to another example. As you can see here, integration of sin x plus cos x bracket close dot dx. This example is based on addition and subtraction rule. Now we separate these two functions and integrate them individually. As we know that integration of sin x is minus cos x and integration of cos x is plus sin x, and we add a constant here. Let's move to another example. As you can see here, integration of x cos x dot dx. First we have to analyze it. This form of integration is based on integration by parts. So to solve this we have to assume one as u and second as v. But question is that how we assume them, that which is u and which is v. To solve this types of problems, we have one concept as you can see here. This is ILATE, where I means inverse function, L means logarithmic function, A means algebraic functions, T means trigonometry functions, and A means exponential functions. This is the order to take u and v. As u comes first, then choose such function which comes first and take other as v. Here we can see that x is algebraic function, and cos x is trigonometric function. So x is taken as u and cos x is taken as v. To solve it we follow the formula, and write it as x integration of cos x dot dx minus differentiation of x integration of cos x dot dx. And this whole term again integrated by dx. Solve it and we write here x sin x. As we know, integration of cos x is sin x minus integration of sin x dot dx. Now we can write x sin x minus cos x bracket close plus c. So we get the solution x sin x plus cos x plus c. Let's move to another example. As you can see here, integration of x upon x square plus 1 dot dx. This example is based on substitution rule. We put u equals to x square plus 1 and differentiate it, then we can write do is equals to 2x dx. Here we can find the value of x dot dx. As we simplify this we can write x dot dx is equals to du upon 2. We can replace each term by substituting u and du in give condition. At the place of x dot dx we put du upon 2. And at the place of x square 2 plus 1 we put u. When we solve this we get this answer. Now move to the next example. As we can see here, integration of 3x plus 2 whole to the power 3 dot dx. Now we have to analysis this integration form. What is the format of this question? If we differentiate the term 3x plus 2, then we get 3. Now what we have to do? We will multiply and divide the question by 3. When we divide the question by 3, then we can write here 1 by 3 integration of 3x plus 2 raised to the power cube 3 dot dx. Now what is the difference between question and this condition? As you can check this condition, there is no difference between question and in this condition. Now we get the format or rule of integration, that is substitution rule. So we can say this question is based on substitution rule. How the substitution rule working here? We put here is equals to 3x plus 2. Now differentiate it, and we get 3 dot dx. So we can replace each term in the question. Now we are going to replace each term. U replaced by 3x plus 2. So we can write here 1 by 3 integration of u raised to the power 3 dot 3 dx. We have replaced 3 dot dx by du. Now integrated and we get the integration of this question, or we can see solution of this question is 1 by 3 dot u raised to the power 4 upon 4. Now simplify it and get answer. Now we will talk about application of definite integral. As you can see here, there's a graph. And in this graph fx is in the y direction, that represent function of x in a and b lies in the x direction. A and b here represent the limits of area of the graph. So we have to find out the area of this graph. To find out the area of this graph we take a small element dx. So to find out the area of this graph we have to integrate dx up to given limits. We can write here integration of fx dot dx and limits tends to it to b. Now to understand it more correctly, we are taking some examples of definite integral. As you can see here, fx is equals to 2x square plus 2x plus 1. And the limits is tends to 4 to 7. Now we can write the function like as integration of fx dot dx limits tends to it to be is equals to integration and limits tends to 4 to 7. 2x square plus 2x plus 1 dot dx. Is it clear now? You have to integrate the whole term. Now you have to integrate this. When we integrate x square we get x raised to the power 3 upon 3. When we integrate 2x we get x raised to the power 2 upon 2. Plus the integration of 1 is going to be x. But how integration of 1 is going to be x? Let's see here. For 1 we can write. We can write here x raised to the power 0. When we integrate x raised to the power 0 then we have to write x raised to the power 0 plus 1 upon 0 plus 1. Then we will write the integration of 1 is going to be x. And we put both the limits 4 and 7. Now again simplify this and put the 7 at the place of x, then minus and put the 4 at the place of x. Now solve it and you will get the answer. It is the example and my motive is to let you understand that how can we solve this type of definite integral functions. You don't need to solve it. And I am not solving. It's complete here. Thank you very much dear students. Thanks to see this lecture. I hope you love it and you get more understanding about integration. If you find any difficulty and if you have any problem then please feel free to contact us. We are here to help you, and if you like this video then please like, comment and share this video. You can ask any question to us and we try to give your answers. If you want video on any topic then you can comment me or contact us. All the information given in the description. Thank you very much.